Welcome, everyone. Thank you for joining us today for the Apigee Hybrid webinar. A quick introduction. Today, we're going to be speaking about the Apigee Hybrid launch, which we launched a few weeks ago at Next in beta. And today, Nandan, who is a product manager in Google Cloud, and he's the one who worked on it the most, is going to be diving into all the details, doing a demo, and speaking about how Apigee Hybrid fits into the broader Apigee offerings that we have. Feel free to submit questions at any point in time. You can submit them right away, and we will try to answer them throughout the presentation, as well as we have some time set aside at the end to answer those questions. My name is Shika. I am a product marketing manager with Google Cloud, and I'll be the host for today. And I'm going to turn it over to Nandan now. Thank you.
Thank you so much, Shika. So let me give you guys a quick overview of today's agenda. I'll very briefly talk about the Apigee API platform, what are the capabilities available, and then talk about what are the hybrid use cases that we have seen with customers so far and what we have in our current offering, and then talk about the new offering that we have and how it is different from the current hybrid offering that we have. Then we'll talk about some use cases, what we've seen with customers, and some guidance on when to use which type of gateway. So with that, let's start a very brief introduction to the Apigee API platform. I know too many of you have seen these slides, so I won't spend too much time on them, but it's always good to start with a quick foundation of where we are and how this matches with our current offering set. So Apigee is a full lifecycle API management product, and obviously what does full lifecycle mean? It goes back to the beginning of what is an API lifecycle. Any good API should start with API design. And if you had asked me a couple of years ago, API design, and I would have always said open API specification, or Swagger as it was known a few years ago, would have been a great place to start. But as we're seeing today, APIs come in other shapes and sizes. We're seeing a lot of GraphQL being adopted by enterprises. We are also seeing gRPC as a popular form factor. So API design now more than open API spec, but fundamentally the fact that you start with a design hasn't changed. And then the natural evolution of that API is then you go into developing that API, securing that API, and deploying it. And it is really deploy that we are going to talk more about today. Where do you deploy it? What has changed in the form factor of where do you deploy is what we are going to talk today. The rest of the pieces of publish, monitor, analyze, and monetize really hasn't changed, but we'll briefly go over them as we talk about deploying APIs in multiple platforms. So this is the slide that we have that talks about how Apigee fits into a typical enterprise. Your enterprise has many types of applications. You're probably building new applications with microservices. You still carry a lot of legacy applications, and they've all not necessarily moved. And you're also consuming APIs built by other vendors from Salesforce, from Workday, from other SaaS providers. And at the end of it, API management is super critical for the consumption layer, because at the end of the day, what you want to do is take all these assets, these business assets that you have, and make them available to your consumers. So if I had to succinctly put what does API management provide, it manages the relationship between providers and consumers, providers of APIs and consumers of APIs. So from that perspective, we've got 3 or 4 fundamental building blocks. We've got the runtime, we've got monitoring analytics, and of course, the developer ecosystem. So how do these impact from a hybrid perspective, or what specifically does it change from a hybrid perspective? Let's focus first on the runtime. From the runtime perspective, we had 3 types of gateways available today. In the cloud as well as on premises, we had the enterprise gateway. For hybrid, we had micro gateway and Istio as the 3 types of gateways that we had available to customers. From a mediation perspective, this is an API provider trying to connect that API to different sets of systems. The use cases that we saw were security, transformation, orchestration, abuse prevention, and of course, extensions. Some of these features we introduced recently. Take, for example, extensions. We announced extensions in second quarter of last year, which provides developers with the ability to connect to cloud services like data loss prevention to mask or obfuscate the API content, to connect to, say, Google PubSub as an integration to your messaging platform. And now we have started adding services that are outside of GCP, like with AWS and also Salesforce. So extensions and the runtime assets are really providing those tools to the developer and improving the API provider's productivity by giving them tools to build and connect to different sets of APIs. In the same vein, security is also an important aspect of exposing APIs. You probably want to do security mediation because not all of your applications talk the same security language, and it's important to mediate between them. So from a provider's perspective, as you're building APIs, you also want to be able to monitor and analyze them. And these are typically different personas that look at this. The persona of a production operator is going to look at your fleet-wide set of APIs and look at it. How are all my APIs doing? Are they throwing errors? Are they measuring or keeping up to the latency? Is it not too high? And things like that. But as an API provider, I don't care about the fleet-wide aspects of my API program. I really care about APIs that I have developed. And for me, things that are important is which is a consumer that's consuming my API, what type of client devices are they connecting from, if I am upgrading my API, who gets impacted, and so on. So different sets of personas, but these are also critical from an API management perspective that you have all this data available to them. And last, and perhaps most importantly, all of this is done to make the consumers highly productive. You want consumers to find a single catalog of all the APIs that are eligible to access, and once they can access them, that they can request access to it, and you as a provider can manage who or which of your consumers can get access to these APIs, how much of it can they get, and so on. So it really comes down to this, right? The catalog or the portal becomes that key place where you manage that relationship of consumers coming in, hopefully self-service, that they can auto-register, come in, see the set of APIs that they have, and you as a provider deciding how much and whom you want to grant access to. And this forms the fundamental of an API management platform. So with this, what really has changed? What we have seen is that enterprises are in a flux of moving workloads from their data centers to clouds. And a lot of times it is lift and shift. In some cases, it's also lift, modernize, and shift. Right? So what does that mean for API management? What it means for us is that in our enterprises, we see that APIs are going to be in multiple places. Some APIs are going to be on cloud, and usually enterprises are picking more than one cloud provider because they don't want to put all their eggs in one basket. And there are going to be some APIs that are never going to live on premises. And on premises or some data center footprint is going to be a reality for a lot of these enterprises, and that's not going to change either. So Apigee's current offering, which is primarily in twofold, which is a completely SaaS offering or a completely on-premises offering, was what customers had the ability to pick from. Now, the completely SaaS offering, of course, worked when you had your workloads already moved to the cloud, or if they already remained in the data center, and the cloud platform could route requests either to one or more cloud providers or to your data center. For enterprises that were kind of apprehensive about shifting workloads to the cloud, they had the fully on-premises version of Apigee, and then they could run it in their data centers. So what really changed? What was missing? One concern that customers have expressed with using a fully SaaS offering was latency. Imagine this use case where your consumers and providers are in the same cloud or data center. Now, you really don't want to make a round trip all the way to the cloud to come back in. What you want is to have a gateway much closer to you. From a security perspective, some enterprises have standards where certain API traffic cannot leave their private networks. And again, a cloud offering in that case doesn't make sense because you have your API call leave your network. So in both of these cases, we would have told customers that they could use Apigee's on-premises offering and keep that traffic private. The problem with using a fully on-premises version of Apigee is that now there's an overhead that customers have to maintain the UI, the RBAC, or the SSO for this. They have to maintain all of the analytics. They have to maintain the portal. They have to maintain really the entire stack. And what really they were looking for was the ability to keep the gateways as close to the APIs as possible and not necessarily take on the entire infrastructure. So those are sort of the beginnings of why this was needed. So with Apigee had defined API management, and we started this in 2015, and we'll show you some examples of how we did that, of defining hybrid API management as being this. That there is an Apigee managed control plane that is hosted, managed, maintained by Apigee in the cloud. And then there's a runtime plane that is hosted, managed, maintained by customers on other cloud providers or in their own data centers. And the runtime plane contacted the control plane to receive instructions so it can operate it. What this decoupled architecture gave customers is the ability to deploy just the gateways as close to workloads as possible. That way, latency was no longer an issue. API traffic never left your network and it could stay local. And yet you didn't have the overhead of taking the entire infrastructure and making it available. So what really is part of this management plane? So the management plane typically includes the UI, it includes the RBAC for who can do what within the platform. The UI can optionally include the portal, and I say optionally because some customers like to have custom portals for various reasons, and they should, of course, continue to have that ability to have custom portals. And of course, the analytics. I want to have these gateways asynchronously send analytics information back to the control plane where we can aggregate this and create dashboards. So that is hybrid API management. To have a decoupled management and a runtime plane, you'll notice that I interchangeably use the word management and control plane. Yes, there are some subtle differences, but for the purposes of this conversation, I will interchangeably use those words, a management plane or a control plane. And then you have the runtime plane that can be distributed running wherever, which is receiving instructions from this management plane. So the Apigee had two offerings or has two offerings for hybrid. In 2015, we launched Micro Gateway, and Micro Gateway was specifically addressing the need for an API gateway for microservices. When enterprises started to build microservices, and these were the really early days of microservices in 2015, they were looking for a very lightweight gateway that could do basic API protection as close to the microservice as possible. Things like API key verification, OAuth verification, quota, spike arrest were all critically needed for the API as close as possible. A more centralized gateway would have meant that every one of your microservices would have to go to the centralized gateway and come back, incurring a lot of latency to your microservices, so they really wanted a lightweight gateway there. And Micro Gateway continues to be adopted by our enterprises, and last year we did a presentation with HP where we talked about how HP modernized their microservices using Micro Gateway. So Micro Gateway continues to fill that segment of use cases where it makes sense, where you're building microservices and you need a gateway as close to it as possible. Last year, Google announced Istio. Istio is an open source platform that Google announced with other partners like Red Hat, IBM, and now there are many more people like F5 Networks and so on. And Istio provides a service mesh management infrastructure or a service mesh infrastructure. So Istio is meant to manage your microservices. It provides features that a service operator or a microservice operator would care for. Things that you want built into your infrastructure so you don't want every service developer to think about. Things like MTLS, routing, load balancing, fundamental aspects that not every service developer should think about. So as Istio Service Mesh started becoming popular and we're seeing enterprises adopt Istio, Istio provides a very interesting capability. It adds the notion of a sidecar to every service that you build. And that's what you see here as the proxy. Now, when you already have a sidecar associated with it, Apigee said, well, this is a very interesting use case to do API management as well. The sidecar already exists, and the sidecar is capable of enforcing policies. So what we did in 2018 was to extend the capabilities of Istio, make it knowledgeable about Apigee policies, such as saying API key verification, OAuth, quota, spike arrest, and all that, and have the sidecar proxy implement it or enforce it. So in 2018, we launched another hybrid offering for enterprises that have adopted Istio to manage their microservices. They now get an Istio that is capable of Apigee API management policies. So what then changed? We see that there are an evolving set of use cases that customers, while they micro gateway and Istio certainly fit a certain set of use cases, customers really wanted the capabilities of the enterprise gateway available to them where their APIs are without having to go full-fledged OPDK. So I've got my APIs in GCP, I've got my APIs in Azure, and I've got some APIs in my data center, and I want to manage them the same way I would do it in the cloud. So there were two fundamental requirements that came up. The first is that I want to maintain my API proxy bundle format. So for those of you who've been using Apigee, you're familiar with the API proxy bundle format and all the policies that are capable with that you can do with it. And you will know that micro gateway and Istio cannot do all the policies that the edge gateway does, the gateway that you see in the cloud or that you see in OPDK. So they give you a limited set of policies, but our customers wanted all the policies that cloud had to offer available to them as close to the APIs as possible. The second, both micro gateway and Istio use a YAML-based declaration, which means that you have a different bundle format between cloud and between your hybrid offerings. And really what they wanted was a universal common method in which the same bundle format should work for cloud, should work for hybrid, should work on-prem, and there should be no differences between them. And in response to this evolving use cases, really what they were asking for is the ability to take the enterprise gateway that we have in the cloud that is capable of all this, doing the same proxy bundles, creating all the policies that are available, including the programmability aspect of the edge gateway, and have that available as hybrid. And that's exactly what Apigee announced at Google Next on the 9th of April, where we have now in beta Apigee Hybrid. So although Apigee had two hybrid offerings in terms of micro gateway and Istio, this is the Apigee Enterprise Gateway working in the hybrid mode. Fundamentally or principally, it works the same as the other two gateways. It still has the notion of a centrally managed control plane managed by Apigee. So Apigee would be responsible for the UI, RBAC, analytics portal, and so on. And customers would be responsible for the enterprise gateway that is now decoupled from the control plane, and they can deploy the enterprise gateway in their data centers and other cloud providers and so on. There is an important difference here. This enterprise gateway is available to be deployed only on Kubernetes. Now we will discuss as we go through the demo what Kubernetes flavors and what are the requirements are, and we'll get into details there. But this is again a change of how customers would consume Apigee software. Our OPDK version, for example, is available on VMs. Hybrid is available on containers to be run on Kubernetes. So when we talk about hybrid and that there is a runtime plane, obviously that includes a gateway, and this is the enterprise gateway that you would deploy on your premises or other cloud providers on Kubernetes. But what does this runtime plane really contain? What is it that you as a customer are responsible to manage and operate? Assuming that Apigee takes care of the management plane, that's where you define the policies, that's where you create the API products and so on, what is it that gets shipped to customers? There are four logical components that are shipped. The first is the message processor. This is the API gateway. For those of you who've used OPDK, you would see the message processor because that would be one of the components that you install. And those of you who have been using our SaaS product, you wouldn't know this, but that's what we call our gateways inside as a message processor. That's really the same gateway that we run in the cloud that you're now able to deploy on premises. What this means is that all the proxy bundles that you built on cloud or on OPDK are fully compatible with the hybrid gateway. They don't need to be changed. The second piece that is shipped along with the runtime plane is an agent that is able to replicate data between the management plane and where your runtime plane is deployed. So let's take an example. You have a developer creates a proxy in the management plane and then deploys the proxy to, say, the dev environment. Now, the agent is now listening to any changes that have been happening to the dev environment and now notices that there's now a proxy available in dev, will now make that proxy available to the gateways that are running on premises or on cloud. And that is the job of the synchronizer. It has a certain set of credentials that allows it to access only an environment or a set of environments that you give it access to, and is able to pull information like target servers, proxy bundles, resource files, things that you will create, artifacts that you create in the management plane, and have them made available to the gateways. The third component is Cassandra. Again, our OPDK customers would know that Cassandra is a persistence mechanism we use, and we continue with it. Cloud customers who are not familiar with Cassandra will be pleased to know that this Cassandra is also deployed on Kubernetes. So we get all the benefits of Kubernetes here. We have taken time to build the operator model for this so you can manage Kubernetes in an easier way than you would if you had deployed them on VMs. And lastly, there's a component called Mart, which is an admin server that helps us manage certain entities that are required by the runtime plane. The Mart service is responsible for managing entities such as API products, API keys, access tokens, cache, KVM. These are all entities that are created by the runtime for the runtime, and Mart allows us to administer that. So overall, these are the four components that a customer is responsible for and that they manage. And obviously, the data that is stored in Cassandra never leaves the customer's data center, and it is, or I shouldn't say data center, it's your network because it could have been in another cloud provider, but it's data that never leaves your approved infrastructure. So what happens from a runtime architecture? How do these get deployed? What is the architecture behind it? Okay, so let's look under the hood and see what actually gets shipped. You'll notice that there are a few more components. These are supporting components. And at the end of this, I'll talk to you a bit about the philosophy of how we have built the runtime architecture. The first thing is that with Apigee Hybrid, Apigee ships Istio. Now, this is a version of Istio that we have built into Hybrid. It's not, you don't have to bring your own Istio. It's not a separate thing. It's an Istio version that we ship, that we manage. It's under the covers. And the reason we use Istio is because it solves a lot of problems that we need. It solves the problem of doing intelligent routing, load balancing, TLS termination, and so on. So instead of us having to reinvent that wheel, we really love using technology built by our sister organization in CSP, and we are using it as part of our architecture. So what you're seeing here, roughly each gray box translates to a pod in Kubernetes, and of course the Istio load balance is the point of entry into the runtime architecture. The Istio load balancer is load balancing requests to the message processors, which again is another stateless component that is doing the proxying before the call actually goes to your service. Supporting this infrastructure are a few components like Synchronizer. We talked about it. It's the agent that makes proxy bundles and other resources available to the gateway. Cassandra is where all the runtime data is stored. So the runtime data is as close to the gateway as possible, so it eliminates any latency. We also talked about the admin server Mart and that it is responsible for managing certain artifacts that the runtime relies on, cache, KVM products, and so on. And now let us talk a bit about analytics. How does analytics work? So shipped along with Hybrid is an agent that collects raw analytics data from each of the gateways and asynchronously sends them to the cloud. So from your perspective, as the API producer or an ops person, you're still going to use the same Apigee user interface as you always did to get all the analytics that you're used to, as that you're accustomed to. You would not see any difference between where the gateway is actually deployed. It so happens that some of these message processors are deployed outside of Apigee, but from your perspective, you get common analytics. And the way it happens is through this agent that is able to collect raw analytics data and send it back to the cloud. But a lot of our customers have asked if they can also get, or if they can also tap into this raw analytics information for their own data warehousing and BI processing. And this is now possible without you having to export data out of Apigee. Again, the agent is capable of sending raw analytics information to more than one destination. One of those destinations would, of course, be Apigee. The second destination could be something of your choice. You could use GCS, S3, whatever is your favorite data lake. It can be routed there, and now you have a copy of the raw analytics as well. So the overall architecture of what gets deployed are these components, and it follows a fundamental philosophy of open fail or fail open. What does that mean? You'll notice that all the critical pieces for the success of your API call is all available at the infrastructure that you manage. Should you lose connectivity to the cloud, so that's two components, Mart and Synchronizer, that kind of tether to the cloud, are not able to tether to the cloud for whatever network failure or other problems that you may have. All the information that the gateway needs to continue processing APIs are already available, and you won't notice any failures. Yes, it is true that you won't be able to deploy a new proxy at that point or create a new cache or a KVM, but any information that already made it through before the failure is already present. And this is very critical when running mission-critical applications on Apigee, that a constant tether is not necessary for your processing of APIs.
We actually have a few questions on the architecture, so why don't we take a couple of them right now. One is router and Istio the same?
So I presume the person who asked this question is familiar with OPDK. The job of the router that we had in OPDK is now replaced by Istio's ingress gateway, yes.
Okay.
But it does more than what the router did. So it, of course, does what the router did, and now it does a lot more, and my following slides will explain what the additional features are.
Okay. Does Cassandra and runtime architecture is it used only for caching, or is it also temporary storage for analytics before they are pushed to the cloud?
Cassandra is not used for analytics. So Cassandra is used for the following use cases. API products are there, access tokens, API keys, cache KVM are the entities that are stored in Cassandra. Nothing else is stored there. And this data that I'm talking about, which is, again, cache KVM, access tokens, keys, products, and all that, is only stored in Cassandra. There is no copy of that maintained in the cloud. So this data is only persisted in the customer's Cassandra.
Okay. Is there TLS between all the runtime components deployed in my data center?
Yes. All components have TLS or MTLS, your option.
Okay.
At least one-way TLS is mandatory. Two-way TLS is up to you.
Okay. Let's move on, and we'll come back to the rest of the questions at the end.
All right. So what actually gets deployed, and how are they deployed on Kubernetes? Like I said, the runtime architecture depends on Kubernetes. It is not available on a non-Kubernetes platform. And the reason for that is we don't want to reinvent a lot of the goodness that Kubernetes brings with respect to upgrades, auto-scaling, and things like that are already built into the platform, and no point in us trying to reinvent that wheel. So most of the applications that we deliver are stateless, including the synchronizer, which is replicating data. You blow on and you bring up another, it's going to pull the data again. So effectively, it is stateless. But the important thing that is stateful is Cassandra. Cassandra is a stateful set, and part of the architecture relies on at least Kubernetes 1.10 or higher. So if you're on a lower version of Kubernetes, you may want to think about creating a new cluster that is at least 1.10 or higher. Now, of course, you'll get more benefits when you go into some of the higher versions, but this is the minimum version that we are targeting. Now, we've taken some important steps here to make the operations of these components much easier, right? So, of course, they all use the horizontal pod autoscaler, the stateless components. And when you are dealing with a stateful component like Cassandra, we are building automated backup, and these automated backup primarily work when you're running in other clouds like GCP, AWS, or Azure, because they provide us with some capabilities that we can rely on to exist. And so you as a production operator can configure these automatic backup tasks so we can take backup of Cassandra and store it into, say, S3 or GCS, depending on where you're running. So these are the architectural details of how we are deploying this on Kubernetes. Again, if there are questions, we can come back to it at a later point in time. All right. What we're going to do now is we're going to do a demo, because I talked to you a bit about the architecture. It makes sense now for you to sort of see the demo in action, and then we'll come back to some slides and I'll walk you through some more architectural bits, and they'll start to make sense once you see the demonstration. Right? And that may also give you the opportunity to ask other questions based on you seeing the demo, and those questions will come towards the end. Okay, so let's start with the demo. Okay, let me quickly walk you through the setup that I have. I've got two clusters here, and of course I'm using GKE here. I've got one cluster, Apigee, and that already has everything configured. Everything is set up. But that's not the demo I want to show you. The demo I want to show you is a cluster that I've got, which is webinar. And you'll notice here, when I click on workloads, all the things that I've created are on the Apigee cluster. The webinar cluster is completely empty. Right. What I want to show you today is, first, how did I set up this cluster? What are some of the best practices when you set up clusters? And then going from 0 to 60. All I have is an empty cluster, and I want to get hybrid going. How quick is that? What does it mean for me? Right. So it'll take a minute to spend about what is it that I have done to my Apigee, to my GKE cluster. So on this webinar cluster, you'll notice that I've got two node pools. I've got a node pool for the runtime, which I've got 3 nodes for. And I've got one separate node pool for the data, for my stateful set, which is Cassandra. Usually what we would recommend is that your stateful set has a high-speed data, so either a local storage class or a local with SSD would be ideal from a performance perspective. Your runtime, which is stateless, can be its own node pool, and obviously they can scale independently of each other. Zoom in. All right, is this better? Cool. You'll also notice that I've got something interesting going here with respect to leveraging secrets and encrypting them. With hybrid, and we'll go into this into some more detail, I've got a slide on this. A lot of the application secrets, like encryption keys, your northbound TLS certificates, and so on, are leveraging Kubernetes secrets. And when you leverage Kubernetes secrets on platforms such as GKE, you could use something like an HSM or KMS as the repository for where these are stored. And these are then made available to this. So anybody in industries where they're highly regulated, the ability to store such sensitive data on an HSM will be very useful. So I turned this on so you can see how that works. So very, very briefly, that's what I've got. I've got a single node or a single region cluster, and I'm going to set up Apigee on this, the hybrid on this. The second piece I want to bring up is that there is a YAML file that you specify where you specify the details of what is it that you want installed on this cluster. Because while you have these 4 components, they don't necessarily all have to go into the same cluster. You could move your stateful sets to one cluster, your stateless components to another cluster, and so on. Given that flexibility, you need some sort of a configuration file to know where goes what. So here is a YAML file that I've got, which we call the overrides.yaml. And I've specified in it certain details about, for example, what is the credentials I need to pull the images the Docker images first. We sign all our Docker images, and they're made available in Docker Hub, so you can configure your cluster to trust images that are only signed by us. Second, you specify things like what certificates to use for my runtime, what certificates to use for Cassandra, whether you want MTLS or TLS. These are all things that you specify in this overrides file. Now, a lot of these details I have explicitly said. Not all of them are needed if you're doing a very simple POC type install. You can skip a lot of these details, and we assume some defaults, which are not always acceptable for a production deployment. So I've got this overrides.yaml where I've specified for each component what it is that I want, what happens next. Now I'm going to switch to my terminal, and I'm going to walk you through what happens next. Apigee has shipped a utility called Apigee Cuttle, right? Kind of sticking with the theme of kubectl and istio-cutl, there's now Apigee Cuttle that helps you manage the deployments to the Kubernetes cluster. Now, I know some enterprises will use Helm, some will use Kustomize, some will use a whole bunch of other tools to manage it, and therefore this is an optional tool. It is a tool that can help you, at least initially, to understand how we generate the Kubernetes manifests. So I use Apigee Cuttle and pass the overrides.yaml. This allows me to create a Kubernetes manifest. Now, if I run Apigee Cuttle with a dry run setting, then it will only generate the Kubernetes manifest and not actually deploy it. You can, at this point, customize it, change it, make other things to it, and maintain your own set of Kubernetes manifests that you can deploy later. And if you go into the folder beta, you'll notice that we use the Go templating, which is kind of what other standards like Helm also use. So it is very similar from that perspective of what we have followed, but because not every enterprise will have Helm, nor should we assume that everybody has Helm, this utility is handy to get you started. What I've done is I have in my shell script written a couple of lines of code that set up the namespace, create the Docker, and then run this command to apply the overrides.yaml on my cluster. So that is what I'm going to do now. I'm going to hit setup, and this is going to do it. And what we're going to do at the bottom is start to watch what happens. And you'll notice below that all these pods are getting created, and we're going to give it about a minute for this to finish, right? And in the meanwhile, while we wait for this clusters to set up, let's take a few questions. The whole setup takes about 3-4 minutes-ish, give or take. And at that point, we'll go back, and now I'll walk you through what I'm going to do next, which is to actually test it, right? So all I did was create a cluster, a completely empty cluster. I had nothing else on it. I had a YAML file where I declared what is it I wanted installed on my cluster, how many replicas, and so on. Then I ran my command, and now I'm going to let Kubernetes do its thing of setting this up.
Great.
Okay, Shika, some questions?
Yep, I actually see a bunch of questions on the Kubernetes piece, and sure. I think one theme is, can runtime be deployed on Anthos, GKE on-prem, AWS EKS?
Yes, the answer to all of them is a yes. In fact, on Anthos, there is a slide that is going to come up of how we integrate with Anthos specifically. That should cover GKE on-prem. But EKS, AKS, all supported, yes.
Okay, great. Can you run the containerized runtime environment on other container orchestration environments like ECS?
Yes, ECS is a no. Same for Cloud Foundry is a no. At the moment, they have to be Kubernetes-based.
Okay, great. Are you replacing Micro Gateway with this new runtime?
No, I think Micro Gateway fills a use case that for microservices that the enterprise gateway doesn't, and that will continue. In fact, I see Micro Gateway working in conjunction with the enterprise gateway, where for your microservices, you continue to use this, and for other services, you could use the enterprise gateway.
There are also a few different questions around existing customers who are either using OPDK or the SaaS solution. Can you talk in general about how someone who's using OPDK today could try out hybrid and how that would work, and similarly for the SaaS version?
Right. So to try out the product, of course, please contact your account rep. And then we can work with the account rep to sort of provision an org. You'll notice that in the documentation, and I'll show you the documentation in a minute, which talks about all the prereqs that are needed. And one of the prereqs is that you need a hybrid-enabled org to be created in the cloud. And once you have that, once that org is created, then you can try out hybrid.
And is that, I think there's a question about where the orgs are, if they can be on private cloud or if they can be on public cloud.
Given that the management plane is always Apigee managed, your org will always be created in the cloud by Apigee. And once you have that hybrid enabled org, you can try hybrid. Okay, so it took me about roughly 2 or 3 minutes to have the setup completed. You'll notice very quickly here, we've got Cassandra, and then we've got some jobs that create the Cassandra key spaces, the users, and so on. We've got logging, and I'll come to that in a minute. I've got my synchronizer pieces running. I also have my message processor here. It's called MT, and that's running. Well, all my pieces are more or less good to go and running. So at this point, let me see if I've gotten a public IP address. And once I have my public IP available, I should be able to try this. Right? So let's go to cluster, and let's go to webinar, and let's wait for this. All right, so I've got my public IP also available. So this is the IP address that, because I'm running on the cloud, I can use the service type as load balancer, and it automatically creates a load balancer for me. If you're running this on premises, then you would use a node port mechanism, and then you would have something like an F5 load balancer in front of it, and that would act as the inbound IP address to your message processors. So at this point, I'm going to copy this, but before I actually run something, I'm going to show you a couple of things, okay? Hybrid demo 1, okay? Let me go to API proxies here, and I had a sample proxy deployed, right? This is the hello world that comes with every org, and this is what I had deployed. And you'll notice here that the pods are asynchronously sending deployment status back to the control plane. So when I deploy something, they asynchronously communicate, did that deployment complete? Now, I take a minute after I show you my curl command, what actually happens here with respect to deployments. So bear with me, let's quickly try it. I've got a sample proxy there, so I'm going to hit curl, and I'm going to, oops, I didn't copy it. So let's go copy this here, and v0 hello minus k, because I use a self-signed cert, and I got hello guest back, right? So my proxies already got deployed, right? So now let's see what actually happened and how does this change? How does your developer flow change, right? In this org, I've got a bunch of API proxies deployed. I'm going to deploy one now so I can show you what actually happens, right? And then we'll switch to the analytics view and see what happens there. All right, and I'm going to actually deploy this API proxy to this other cluster that I have. And deployments are now asynchronous, right? It's really you're submitting a request for deployments because the gateways are no longer attached to the control plane. What you've effectively done this is submit a job to say deploy this. And now the synchronizer, which is listening to these events, will eventually, it polls every 60 seconds. That's the poll interval I set up. And so within 60 seconds, it's going to listen to this change, make it available to the gateway, and then communicate that response all the way back, at which point I will know that the API proxy was deployed. So we'll give this another 30, 40 seconds to see the deployment went through, but we'll come back to this page in a second. Let's look at a few other components. With hybrid, we've taken some important changes to the architecture. Oh, there you go. It reported that the deployment was successful. You'll notice that the change was asynchronous. All right, that's good. That was something I wanted to show you guys of how deployments work, which is going to be different from how you typically did this. Okay, let's quickly take a look at some important changes that we have done from an architecture perspective. Right? If you look at the workloads, you'll notice that we are shipping a few other pieces, which are new components that are shipped as part of Apigee. Let's pick the webinar cluster. Right? Here we have a few components called metrics, and then we have logger. Right? So with metrics, Apigee ships Prometheus, and Prometheus is important for two reasons. First, Prometheus becomes a relay point from where we push all the analytics to Stackdriver metrics. Now, Stackdriver metrics will be offered as part of Apigee or Apigee Hybrid. So it's not a separate thing that you have to go get, but it will be included as part of Apigee monitoring. So you get basic alerting, monitoring, all those things that you would have needed to manage your runtime are included with this. Stackdriver automatically gives us these capabilities, and those are included in the platform. The second piece is that we include the Apigee logger, which automatically sends logs to Stackdriver. Again, all the logs from your gateways, from your Cassandra and everything else automatically goes to Stackdriver, where you get a robust logging search mechanism that is already shipped as part of the product. Having said that, these may not necessarily be your enterprise standards. And if you had an enterprise standard to say AppDynamics, New Relic, or something else, then by all means, you should be able to configure those as well. Because we use Prometheus as a relay system, you could use Prometheus as a point from where New Relic or AppDynamics or something else picks it up from there. Because we use something like Fluentd to ship data back to Stackdriver, that could be the point where you also add a stanza and ship logs to other platforms as well. So while Apigee will certainly be opinionated and provide these dashboards through a Google GCP-centric view of Stackdriver logging and metrics, you're free to configure other platforms as well. What happens with environments and load balancing and routing? And this is part of the reason why we introduced something like Istio. With hybrid, we want to stop environments as more as an SDLC platform where you have a dev, a QA, a test, and so on. You have to start thinking of environments as sandboxes, right? Why is that? Well, we've shrunk the size of a message processor so it can be containerized and you can run multiple pods in the same worker node in Kubernetes. Second, we've made environments self-serviceable so you can create as many environments as you want. So the environments have now become sandboxes. So create many environments. If you're running production, create prod 1, prod 2, prod 3, prod 4, and so on, many environments, and each environment a sandbox which contains proxies of similar workload. So now you don't have a noisy neighbor situation. One proxy gets massive amount of traffic, other proxies are not being auto-scaled. As a result, it's only that proxy that is. Now, in the previous model, the challenge with having many environments means that your virtual host is also many. And that's a terrible user experience. You don't want to have prod1.api.com, prod2.api.com, and so on. But with the load balancing that we're doing with Istio, we're now able to make it intelligent enough where the load balancer is able to send that request to the appropriate environment. Right? So although you have many environments, they will have the same domain name or the same virtual host through which they access their APIs. So you get your isolation, you get the scaling that you need while not having to reveal some of these infrastructure details to your consumer. A question I get asked a lot is, hey, I'm not using Istio as my ingress, I'm using something else. What happens? Well, first off, to be pedantic, Istio doesn't use the ingress notation. It uses a gateway notation, so it's not really an ingress from that perspective, but feel free to add something else on top of the Istio ingress, like an F5 load balancer or something else, but the Istio ingress is a part of the Apigee install. We control it, and we need that to be there to be able to do some of this intelligent load balancing that we do. Two, the TLS certs and keys that are used for the ingress, they're all stored in Kubernetes secrets. So that's not information that even comes to the control plane. Now, we talked a bit about secrets management. Secrets are used in a number of instances. We use secrets to store encryption keys for your encrypted KVM. We also use encryption keys to encrypt your cache. All of these secrets are now in the Kubernetes secret. And in the example I showed with GKE, I used an HSM to store my encryption key. Also, your TLS secrets are stored there. And if you're using Kubernetes 1.13, all the information in etcd is also encrypted. How would multi-region expansion work? Well, most of these components are stateless. The only stateful thing is Cassandra, and you would expand this by creating additional clusters and creating a ring that expands multiple regions. All right, so now we've got three options, right? We've got micro gateway, we've got the Istio adapter, and we've got hybrid. What option is right for you? So first off, let's understand what features are there in the Apigee platform and what's available in hybrid. It is Apigee's goal to make Apigee hybrid feature equivalent to cloud. It shouldn't matter who manages your runtime, Apigee or our customers. All the features that you get in the cloud, you should get with hybrid. Some of these examples like bot detection or hosted targets are currently not available in our on-premises version, only available in cloud. But with hybrid, all of these features will eventually be available with hybrid as well. So with that, here's a quick summary, and I'm not going to dwell too much into this. We'll make available these slides through the webinar, so you will have access to this information. But I'm going to quickly go through because we're running out of time here. Let me very quickly give you some guidance on what you pick when, right? The first question you need to ask is, do you want SaaS or hybrid? Which is, do you really want to manage anything at all, or do you want to let Apigee manage all the infrastructure? If hybrid is the answer, then the next question becomes, well, what are you trying to manage the APIs for? Are they for microservices, or are they for a mix of old and new? Right? So if it is just microservices, then you could use either micro gateway or Istio if you're using Istio, and then that becomes your choice of gateway. If your policies are going to be more complicated than that, where you want to have all the advanced features of the Apigee Edge platform, then Apigee Hybrid would be the right answer for you. So this is a very, very high-level view. I'm positive that when you actually get into individual customer scenarios, there'll be more questions than this. I'm going to take 30 seconds to talk about Anthos and how we run with Anthos. Anthos ships with GKE, eventually with CSM and Cloud Run. Apigee works on top of GKE on-prem, and eventually we'd be looking for integration with CSM and other parts of Anthos as well. So immediately, we definitely support GKE and GKE on-prem. That's our integration with Anthos. And over a period of time, we will support other features as they become GA. CSM is not GA yet. So cloud services management, which is managed Istio, when it becomes GA, we will start integration with it as well. So with that, I'm going to pause now and go back to Shikha.
Okay, great. As you know, we run out of time for questions. So here's what we'll do. You can email your questions, which is apigee@google.com. Feel free to email questions there. Also, if you want to try out Apigee Hybrid and beta, feel free to send an email there. What we will do is we'll take all of these questions. There's some great questions. We'll make sure that our docs team has access to those, and they will try their best to incorporate that into the documentation. And feel free to post on the community. I think there's some questions on the community as well. We'll go through and answer those there. And with that, thank you so much for joining us today and for asking some great questions. Thank you.